Hello everyone, welcome to your first Python programming tutorial on GNU plus Linux. Today we'll be going over setting up the Python programming environment and also getting you familiar with using the interpreter and writing your first program. We're going to begin by opening up a file manager. I've created a folder here called Py, and inside of it I'm going to create a new folder called Tutorial. This is where all of our tutorial videos will go. So, I'm going to make a new folder called 01 for the first tutorial. And the first thing we're going to do here is open up a terminal. You may not have this open in terminal thing. If that's the case, then you can open up a regular terminal and go to wherever your folder is, and then you're in the same place. The first thing we're going to do is install the Python interpreter. We will need this to run any of our Python programs that we create. On Debian GNU plus Linux, you can do this by typing sudo apt-get install Python 3. You need Python 3. We will specifically be going over the Python 3 version of Python in this series. It is distinctly different from Python 2 in many ways, and if you just install Python, your distribution nowadays will probably install Python 2 instead. So we want to be explicit and get Python 3. We'll enter our password, and it's going to tell me that I already have it, and that I don't need to install it because, well, I've had Python for a while. However, you'll be able to install it, and then after that, we'll be able to run the interpreter. We can do this by typing the name of the interpreter. You want to type Python 3 and spell it correctly. What you're looking for here is Python 3 dot something. I'll be using 3.4 for my series, but if you're using 3.3 or 3.2, that's still probably going to be fine. I don't believe I'll be using any 3.4 specific features. Make sure it does not, however, say Python 2 point something. We do not want that. So, Python 3. Alright, now that we've checked the version and we've made sure that we are in the correct interpreter and everything is installed, you should be prompted with these three arrows here. This means that the interpreter is ready to receive a command from you, which should be in Python formatting. It should be some Python code for it to execute. So, we'll write the first program. As is traditional in any programming language, the first program is to write Hello World on the screen. You can write something onto the screen using the function called print. Any function can be called by declaring its name, print, and then opening a left parenthesis. Then we pass the function's arguments. Each argument is some sort of value that we pass to the function, and then it does something with those data. For print, we tell it what we want it to print on the screen. In this case, we open up a string. We can do this with single quotes or double quotes. Both work. I'll use single quotes because they're easier to type. We type hello world. We close the string with the same mark that we used to open it. So if you use double quotes, then you need to use double quotes to close it. If you use single quotes, then you need to use single quotes to close it like I have. Then, when we're done passing the arguments, you must close with a right parenthesis. And then Python accepts the end of a line to be a new line character. We can insert that by pressing enter. So when I press enter, it will execute the function print with the argument hello world as a string. And as we see, it printed hello world on the screen for us. Alright, so that is the simplest way to execute Python code, is just to type it directly into the interpreter, but this is not the most intuitive way for your users to execute your code. You can't ask them to open up a Python interpreter and type your code into it in order to get the program they want. After all, it doesn't save it. So here's what we do. To exit the interpreter, we can type exit, open parenthesis, close parenthesis. For a simple exit, this is all that's needed. We don't need to pass any arguments to it. This will close the interpreter. Now, because of the way that interpreters work, you could also type Control-D if you're using the bash shell, as I'm doing. That's what I did in these two times up here when I exited the interpreter. Okay, so let's make a file instead, because your users will want to run a file. So, we'll create a new document, a blank document, and we'll call it hello.py. Py is the standard extension for Python code. So we'll open this up in some text editor. I'm going to be using GNU Emacs, but feel free to use any text editor you want. It will open it up in Python mode if you are using Emacs, which will be nice because we'll have syntax highlighting for our code. Now, we can type the exact same thing. We'll type print hello world. Now, notice that it has highlighted things based on the syntax, so our string here has a special color to it to indicate that it's a string, and print is a built-in function, so it gets highlighted as well because it knows that it is a function call. Alright, we'll save this file. We see that we have stored 23 bytes in this file. Now, we can execute it by calling pytut01 and then the name of the file, hello.py. And yet again, we have hello world printed on the screen. Now, again, your users aren't going to want to have to type pytut01 and then your file.py, so there is yet another way to do this. So let's rename this to just hello with no extension, because on any Unix system, extensions are merely detail and you don't necessarily need them. For files that we want users to execute, we might as well leave the extension off to make it much like other programs like pytut01, which don't have a file extension when we run them. Now, if I just try to run this hello program, it's going to tell me that I can't. So just like any script that we would write, we need to do chmod plus x, meaning that I'm going to add the permission to execute it, and then hello. Now if I list the files, it shows up in green, which means that it's executable. I can run ./hello, and it tells me that I have a syntax error. This is because I did not tell the interpreter, or I did not tell the operating system what interpreter to use for this file. So we want to display it, that is, open it up in a text editor, and we need to tell it what kind of file it is. Let's change to Python mode if you're in Emacs. We need to add the shebang at the top, which needs to go at the top of every file you want your users to directly execute. We'll do this with pound, exclamation point, which I'll call the shebang. The space here is optional, then /usr, /bin, /env, then another space, then the name of the interpreter. In this case it is pytut01. Save this file. Now, if I try this again, hello world. Now I've told it to use the correct interpreter. Then, so when it starts pytut01, it begins reading. It sees print hello world, and so it prints hello world. Anytime that I use the term print, I mean to put it on the screen. This has nothing to do with any sort of external printer. There are different terms that we will use for that. Now, although I've shown you how to create a program in a file and have your users execute it, let's go back into the interpreter itself and show the usefulness of being able to type straight into the interpreter as a developer, which is what you are. So, let's do a bit of math. Your computer is, after all, a glorified math machine. That's really what it's best at doing, is mathematics. That's all the job of the CPU. So, let's see 2 plus 2. Now, 2 plus 2, if I were to type that in our file here, hello, and run it, it would actually not show this 4. But the interpreter knows that you want to see the return value of some expression that you typed. 2 plus 2 is an expression, and that expression resolves to the value 4. And so it shows you what it resolved to. Print has no return value, so it only did what the print did, but didn't actually show a return value. Alright, let's do 6 minus 5. That shows 1. Notice that the spaces here are optional. I could have easily done 6 minus 5 like that, and I could have done 2 plus 2 earlier. I'll generally put spaces because I find it to be more readable in the code. Alright, now multiplication. 3 times 8 is 24. Now, this is something that's different in pytut01. In pytut2, 5 divided by 2 would have returned 2. This is because pytut2 by default saw that 5 and 2 were both integers and returned an integer value. However, in pytut3 it knows that we actually want the real answer to 5 divided by 2 and not just an integer. So it's going to give us 2.5. Now, if we wanted to have that 2, we can still do that. It's not a limitation of pytut3. We can do 5//2 to mean floor division, which is the same thing, and that'll give us 2. Now we also have the modulus operator. So if we do 5 modulus 2, modulus is a percent sign, it's going to show us 1. The modulus, what this does, is it gets the remainder of a division that did not go evenly. So, if I were to say print, then 5 floor division 2 plus the string space r, and then plus 5 modulus 2, then I get a type error because I can't add these. So instead, I'll use commas, which will insert spaces between them. So 5 divided by 2 is 2 with a remainder of 1. We can turn these into strings if we really want to add them like I did here, but this is just an introduction to the way that types do not mix together in Python. But with print, you can always put a comma to separate your arguments, and that will insert a space and then the value. And if you type a number, it will always convert it to a string before it prints it, because you can only print strings. Next, we have raising to powers. So if I want to take 4 to the 7th power, I can do 2 multiplication signs, and that will take 4 to the 7th power. Finally, let's use another built-in function. The only function I've showed you so far is print. Let's use another one, abs, which is the absolute value. The absolute value is the distance of a number from 0. So if I do 5, then it returns 5. If I do negative 40, it is 40. Similarly, I can pass other values because of the way they resolve. So I can do 7 divided by 2. And it's going to return 3.5. Notice that this would have been 3.5 anyway, because the absolute value of a positive number is just that number. I hope you've enjoyed this video. If you have any questions, feel free to contact me. The contact page is linked above. And of course, you are free to share this video with any of your friends, along with any of the other tutorials that I make in this series. It's intended for learning, and I want everybody to be able to learn. Feel free to share. Thanks. I'll see you next time.